In question number 2.29, a spherical capacitor is given where there are two spherical conductors, concentric conductors are present. In the inner conductor, the conductor having negative Q charges and outer conductor, conducting sphere, having positive Q charges. Now the electric field is in between the two conductors from positive to negative. We have to find the capacitance of this spherical capacitor. Now this is the system of two conductors. So as we know, the capacitance of this system is equal to magnitude of charge divided by potential difference. And potential difference is the sphere having positive charge and sphere having negative charge. So the first sphere is having positive charge. So we are writing the potential difference as V1 minus V2. Now to find the potential due to charge, you must remember this concept of potential due to spherical conductor. In spherical conductor, the potential at a distance r outside the sphere is equal to kq by small r, and inside sphere and at the surface, this formula is kq by capital R, where capital R is the radius of this sphere and small r is the distance of point from the center of this sphere. Now, first of all, find the potential at a point on this first sphere. At this sphere, the potential is due to these positive charges, and due to these negative charges. For the sphere having positive charges, this point is at the surface. So at surface, the formula of potential is this much. So write down potential as K plus Q divided by radius of this sphere, that is equal to R1. So this is the potential at this first sphere due to these positive charges. Now find the potential at this first point due to these negative charges. For these negative charges, the sphere having negative charge, the point is outside the sphere. So use this formula. So potential due to negative charge is equal to K minus Q divided by distance of point from this center, that is equal to R1. So this is plus KQ by R1 and this is minus KQ by R1. So potential at first sphere is equal to what? 0. Now find the potential at second sphere. Now potential at this point is due to these positive charges. For positive charges, this point is inside the sphere. So use this formula KQ by R. So write down KQ and the radius of this sphere, that is equal to R1. So KQ by R1. Now for negative charges, this point 2 is at the surface. So use this formula. So K minus Q divided by radius of this sphere is equal to R2. So take KQ common, then it becomes 1 by R1 minus 1 by R2. Now the potential difference is V1 minus V2, so that is equal to 0 minus this much. So take this minus inside, so this becomes R2 minus R1. Now take LCM. So this is, the numerator becomes R1 minus R2 divided by R1 into R2. So the potential difference is this much. Write down in place of Q 1 by 4 pi epsilon naught. Now the capacitance of this spherical capacitor is Q by potential difference V1 minus V2. So substitute the value of V1 minus V2 here. So QQ gets cancelled and this 4 pi epsilon naught goes in the numerator. So it becomes 4 pi epsilon naught R1 into R2 divided by R1 minus R2. So this is the formula of spherical capacitor having two concentric spheres having equal charges. So this is the important question for your examination.